Hello, class. We're about to start the last lessons for this semester. We are going to cover sections 5.4 through 5.8 through this video here. Okay, so we're going to start on page 5. We're going to start on section 5.4 on page 525. And as you see, we have problems 1 through 7 odd. Now, the homework actually starts on page 525, but we're actually going to start on page 527 because I'm going to do problems 3 and 5. And as we've done before, you will copy those down, and then you will also do the remaining problems for this section here. So let's go to it on page 527. Okay, and we're starting with problem number 3. It says solve the following equations algebraically and check your results by graphing. Okay, so we have 3a. We have 3x divided by 2x minus 1 equals 3. Now we want to solve this equation here. So in order to solve this equation, the first thing we would need to do is get rid of our denominator. So we can multiply each side by the 2x minus 1. And we could do that by putting everything in this parenthesis here. The 2x minus 1s will simplify out and leave you 3x. Then we would take 3 times 2x is 6x, and 3 times a minus 1 is minus 3. And now we would solve for x. We could subtract 6x on both sides, and we add negative 3x is equal to a negative 3. We'll divide each side by negative 3, and x is equal to 1. Now, before we go on, we have to check and make sure that this 1 does not cause this denominator to be undefined or impossible. So if we put 1 in here, 2 times 1 is 2 minus 1 is 1. So we know that this will actually work. All right, so now we go to 3b. All right, with 3b, we had x plus 1 over 5x minus 3 is equal to 2. Now, using the same logic we just used with the other problem, we need to get rid of this denominator, and we'll multiply everything by the denominator. So the 5x minus 3's will simplify out and leave you x plus 1. Then you will take 2 times the 5x minus 3, which will give you 10x minus 6. Now we get all the x's on one side. We can subtract x on both sides, and we have 1 is equal to 9x minus 6. We can add 6 to both sides, and we have 7 is equal to 9x. We can divide each side by 9, and 7 ninths is equal to x. And when you put 7 ninths back into the original problem, it doesn't make this denominator 0, which would make it impossible or undefined. So that is your final answer. Now we move on to C. We have negative 7x divided by 2.8 plus x is equal to 3.1. Now, in this problem here, we basically do it the same as we did all of the other problems. So we'll multiply it by that denominator, as you see. So we add 2.8 plus x multiplied by this whole equation. The 2.8 plus x's will simplify out, and that'll leave you negative 7x. Now that's equal to, now we need to take 3.1 times the 2.8. Now we can use our calculator. Let me get the calculator. So we could take 2.8 times 3.1. And that'll give us 8.68. And then plus 3.1x. Now we need to get all the x's on one side, so we'll subtract 3.1x on both sides. So this would be a negative 10.1x is equal to 8.68. Now, we divide each side by a negative 10.1, and then that will leave us x will be approximately, we round to 3 decimal places, it'll be a negative 0.859. All right, now we're going to move on to 3D. Okay, so now what we need to do, so we would start this the same way we did all the rest. So we have x plus 10 over 3x plus 2 is equal to 3. So we're going to multiply everything by 3x plus 2. So the 3x plus 2 simplify out, and you're left with x plus 10. And then 3 times 3x is 9x, and 3 times 2 is 6. Now we solve for x, we subtract x on both sides, and 10 is equal to 8x plus 6. Subtract 6 on both sides, 10 minus 6 is 4, is equal to 8x. Divide each side by 8, and we know 4/8 is the same as 1/2 is equal to x, or you can write it as 0.5. Now, they say here to check our results by graphing. So we need to get our calculator. Now let's take our first problem, the 3a, and we will have 3x divided by 2x minus 1. Okay, now this will be our first equation here. So we had 3x over 2x minus 1. Now there is one thing that we forgot to do here, or I forgot to do, is put y equals first, because we're going to set both sides of this equation with y equal to this side of the equation and y equal to this side of the equation. So then we will have y equals 3, and we will go to their intersection point. Their intersection point is at 1, 3, so x is 1, which is what we have for 3a. Now I'm going to go to 3D. I'm not going to do all 4, but you just needed some examples. So with 3D, we'll put y is equal to, you will have x, go back up here, plus 10 in our numerator. And in our denominator, we have 3x plus 2. And then we will go down here and press y equals. And then we will have 3. Now, what I want to do, I'm going to turn these other two off here so we can deal strictly with this equation. And their intersection point here is x is 0.5, which is 1/2, 3. So it does work. All right, now we're going to go to problem number 5. Let's see, problem number 5. Oh, I think it was at the bottom of page 527. Oh, okay. All right, so problem number 5. It says the intensity of the human voice to the listener varies inversely as the square of the distance from the source. This is given by a formula similar to the ones from activity 5.2. Loudness of a voice could be given by I equals 1500 over D squared. So let me write down that formula. I is equal to 1500 all over D squared, where I is in decibels and D is the distance in feet. Okay, determine the distance from the source when the intensity of the sound is 15 decibels. So this is 5A. So they want us to take this formula, I equals 1500 over d squared, and they tell us that I is equal to 15. So we are substituting 15 for the I, and we have 1500 over d squared. Now, we want to find out what d is equal to. So first thing we would have to do is multiply everything by d squared to get rid of the d squared out of the denominator. So we have 15d squared is equal to 1500 because the d squares will simplify each other out. So now we divide each side by 15, and d squared is equal to 100. Now, we would take the square root of both. So we had a square root of d squared and plus or minus the square root of 100. Because whenever we're dealing with an equation and we do a radical that has an index that's even, we always put the plus or minus sign in front. So the square root of d squared is d, and then this would be plus or minus 10. Now here's the issue. You cannot have negative measurement as far as negative distance, which we have here, which is plus or minus 10 feet. Okay, so our distance would just be 10 feet because we cannot have a negative 10 feet. So that's how far the distance is for the 15 decibels. Now we go here to B. What is the distance from the source when the intensity is 8,000 decibels? So we'll do 5B. So we have our I is equal to 1500 over D squared. So they tell us the intensity is 8,000 decibels. So we'll basically go through and solve this the same way we just did the other problem. So we'll multiply everything by D squared. So this would be 8,000 d squared is equal to 1500. We divide each side by 8,000. And we have d squared is equal to, now we know both of these can be divided by 100. So that'll give us 15 over 80. Then we could divide both of these by 5. And this would be 3 over 16. So what we would do here, we have 3 over 16. We'd take the square root of both sides. So we have the square root of d squared and plus or minus the square root of 3 over 16. Now, we know we're not going to use the negative value for this problem. But what we're going to do, we're going to put this in our calculator and we're going to round this to 3 decimal places. So we get our calculator really quick. So we'll take the square root of 3/16. And that rounds to 0.433 feet. And we're done with that problem. So now, we just finished section 5.4. Now we're going to go to section 5.5. Section 5.5 starts on page 536. So now, let me turn this up a little bit here. So we move on to page 536. And the problems that we're going to cover on 5.5 are 1 and 3. All right. So, problem number 1. It says 2 pumps are working together to empty a gasoline tank. The emptying times for pump 1 and pump 2 are 30 minutes and 45 minutes respectively. Determine the time required to empty the tank if both pumps are working. Use the formula 1 over T sub 1 plus 1 over T sub 2 is equal to 1 over T. where T sub 1 and T sub 2 are the emptying times for pump 1 and pump 2 respectively. And T is the total time required to empty the tank. Okay, so that is A. All right, so we will have 1A. So I'm going to rewrite that formula. 1 over T sub 1 plus 1 over T sub 2 is equal to 1 over T. Okay, so now we have 1 over 30 plus 1 over 45 is equal to 1 over T. Now with this problem here, we're trying to get T by itself because we want to know the total time required to empty the tank. So what we have to do first, we have to find a common denominator of all of these. The common denominator of all of these, 30, 45, and T, is 90T. So we'll multiply everything by 90T because it has to be for all three. So 30 goes into 90 3 times. 3T times 1 is 3T. Plus 45 goes into 90 twice. 2T times 1 is 2T. These T's will cancel, and that will give you 90. 3T plus 2T is 5T, which is equal to 90. We divide each side by 5, and T is equal to 18 minutes. So it would take 18 minutes for this to empty. Okay, now we come to 1B. Now 1B says solve the equation 1 over T sub 1 plus 1 over T sub 2 is equal to 1 over T. All right, and we want to solve that for T. All right, so we have to find the common denominator of all these values. The common denominator, T sub 1, T sub 2, and T is all three of these values. So you're going to multiply everything by T sub 1 times T sub 2 times T. All right, so T sub 1 will simplify out. That will leave you T sub 2, T. And then T sub 2's will simplify out. And that will leave you T sub 1, T. And then your T's will simplify out here. And that'll leave you T sub 1, T sub 2. Okay, now, again, we're trying to get T by itself. Now, both of these have a T in common, so we could factor out T, the greatest common factor, and that will leave us T sub 2 plus T sub 1 is equal to T sub 1 times T sub 2. Now, we would divide each side by T sub 2 plus T sub 1, and our final answer would be T is equal to T sub 1, T sub 2, all over T sub 2 plus T sub 1. And that will be your final answer for that problem. Okay, now we move on to problem C. Now it says using the equation developed in part B, determine T if T sub 1 is 20 minutes and T sub 2 is 15 minutes. So we will go to C. So our equation here is T is equal to T sub 1 times T sub 2 all over T sub 2 plus T sub 1. So now we're going to substitute. T sub 1 is 20. And T sub 2 is 15. So it'd be 15 plus 20. All right, so our denominator we know would be 35. Our numerator, 20 times 15, is 300. So now we have 300 all over 35. which if we put that in our calculator, it will give approximately 8.57 minutes. Okay, now we go here to D. It says, if one pump can empty the tank in 40 minutes, how fast must a second pump work for the pumps working together to empty the tank in 10 minutes? And they want us to use the original formula. All right, so let's go through this. So this is actually D. So we will have 1 over 40 plus 1 over T sub 2 is equal to 1 over 10, because we're given these different amounts here. All right, so what we're actually solving for is T sub 2. So we have to find a common denominator of all these values here. The common denominator of everything would be 40 T sub 2. So we'll multiply everything by 40 T sub 2. These 40s will simplify out, and you'll have T sub 2. Plus these T sub 2's will simplify out, and that would be 40 is equal to 10 goes into 44 times T sub 2. Now, we want to get T sub 2 by itself, so we subtract T sub 2 on both sides. So you have 40 is equal to 3 T sub 2. We divide each side by 3. Now 40 divided by 3 would give us approximately 13.3 minutes. And that would be approximately equal to T sub 2. So that's about how fast that second pump has to be. Okay, now we come down here to E. Suppose 3 pumps are working together to empty the tank with emptying times of 25 minutes, 30 minutes, and 50 minutes. How long would it take to empty the tank if all 3 pumps are working simultaneously? Use the formula. So we have basically the same formula except for we have a T sub 3 now. So now we're going to substitute these values in. So we have 1 over 25 plus 1 over 30 plus 1 over 50 is equal to 1 over T. Now we have to find a common denominator of 25, 30, 50, and T. So the common denominator would be 150 T. So we'll multiply everything by the 150 T. So 25 goes into 150 6 times, so this would be 6T. 30 goes into 150 5 times, so that would be 5T. 50 goes into 150T 3 times, so that would be 3T. And these T's will simplify out and leave 150. So now 6T, 5T, and 3T would be 14T. And this would equal to 150. Divide each side by 14. And then you will have T is approximately 10.7 minutes. That's how long it would take for that to empty. Okay, now our next problem would be problem number 3. It looked like the same formula. It says the custodian of mathematics building can buff the main floor 2 minutes faster than his supervisor can. If working together they could buff the floor in 35 minutes, how long does it take the supervisor working alone to buff the main floor of the mathematics building? And it says, hint, let T represent the supervisor's time and T minus 2 represent the custodian's time. Okay. So now, we could start this problem off with the formula. And then we will have 1 over t plus 1 over t minus 2. Now this is the supervisor, this is the custodian, and this is the total time it takes. Sorry about that. So we find a common denominator of all three of these values. So our common denominator here would be 35t times t minus 2. And we'll multiply everything by these values. Now these t's will simplify out. You have 35 times t minus 2. Then for the second value, the t minus 2's will simplify out. And you have 35t. Then finally at the end here, the 35 will simplify out. And you have t times t minus 2. So this would be 35t minus 70 plus 35t is equal to t squared minus 2t. Now, when we combine these like terms, this would be 70t minus 70 is equal to t squared minus 2t. Now, what we should do here, we should move everything over to one side and have this equal to 0, because this looks like this is going to be a quadratic equation. So we could subtract 70t and add 70 on both sides. So this would be 0 is equal to t squared minus 72t plus 70. Now, it would be easier for us to use the quadratic formula. So let's use that. So we have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we know in this case a is 1, b is negative 72, and c is 70. So we have x is equal to the opposite of negative 72 plus or minus negative 72 squared minus 4 times 1 times 70 all over 2 times 1. So x is equal to 72 plus or minus. Now we would do negative 72 squared. We could put that in our calculator. Let me get this calculator going here. So we could do parenthesis negative 72 squared. So that'd be 5,184 minus 280 all over 2. So x is 72 plus or minus the square root of 5,184 minus 280 will give us 4,904. This is all over 2. Now, when we put this in our calculator, once you put all this in your calculator, your final answer would be approximately, t is approximately 71 or 1. Now remember, this is minutes. So we know that this supervisor is not going to be able to finish a job totally by themselves, because they work a shorter time than the custodian does. So the only one that makes sense, the answer that makes sense, is the 71. So our answer here would be t is equal to 71 minutes. So it would take the supervisor about 71 minutes to complete the job. All right, so we are done with section 5.5. Now we want to move on to section 5.6. 5/6 starts on page 542 to 544. And it says 1 through 4 all. So what I'm going to do on this, I'm going to do problems 2 and 4 only. So actually we'll go to page 543 to start with problem number 2. So let me do that. Now it says, if three resistors having resistance R sub 1, R sub 2, and R sub 3 are connected in parallel, their combined resistance R is modeled by the formula. We're given this formula here. Determine R if R sub 1 is 4 ohms, R sub 2 is 8 ohms, and R sub 3 is 12 ohms. Okay, so 2A. Let me write this formula. Okay, now we're going to do some substitution. So we have 1 over R1 is 4, R2 is 8, and then R3 is 12. All right, so let's find the common denominator of 4, 8, and 12. The common denominator of 4, 8, and 12 is actually 24. So we know we have to multiply this by 6 over 6, so this would be 6 over 24. This 1/8, this would be 3 over 24, and 1/12 would be 2 over 24. Now I did that, but we could have done this in the calculator. Let me show you how we could have done this in the calculator. So we could have taken the 1/8 plus, oh, it was supposed to be 1/4 first, but let me go back here. It's supposed to be 1/4. All right, 1/4 plus 1/8 plus 1/12. Now that gave us a decimal, but if we click here, it would have gave us the fraction 11 over 24. So that's one way you could have done it, or you could have done it by hand, because this ends up giving us 1 over 11 over 24. So now we have R is equal to, we're going to separate this and write it as 1 divided by 11 over 24. So R is equal to 1 times 24 over 11. So R is equal to 24 over 11. Now, we could leave it as 24 over 11, or we could write it as a decimal. It'll be approximately 2.18 ohms. All right. Now, one other thing I want to show you in the calculator. Since we know that this is 11 over 24, we could have did 1 divided by, and then put this in a parenthesis, 11 over 24. And then close our parenthesis. Oh, oops. Oh, I hit a button. Okay. So we got 2.18, which we have here. And if we wanted it as a fraction, we could just hit this button here, and it gave us 24 over 11. So that's just something else that you could use when you're doing this problem. All right, now we move on to B. Now B, it says simplify the complex fraction on the right side of the original formula. All right, so basically what they want us to do, they want us to find out what R is equal to, but they just tell us to concentrate on the right side of the formula. So basically, we have 1 over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3. So they want us to get this so that if we were actually, well, they want us to simplify this. Okay, so this is what we need to do. First of all, we need to make sure that this denominator of the bigger fraction does not have a fraction in the denominator. So our first order of business is to do this here. We want to find a common denominator for all of these. The common denominator for all of these is R1, R2, and R3. So let me get another sheet of paper because we're going to need a little bit more space here. I'm just going to concentrate on the denominator for right now. So 1 over R1 plus 1 over R2 plus 1 over R3. And we determined that the common denominator of all three of these are R1, R2, and R3. So we'll need to multiply this numerator and denominator by R2 and R3. Then we have to multiply this numerator and denominator by R1 and R3. Then we'll multiply this numerator and denominator by R2, R1, and R2. So when we do this, we have R2, R3 over R1, R2, R3 plus, this would be R1, R3 over R1, R2, R3 plus R1, R2 all over R1, R2, and R3. All right, so now we would combine these. This would be R2, R3 plus R1, R3 plus R1, R2 all over R1, R2, R3. Now we're going to take this value here. So this would be this here. Put it back in its original place. Now, we're going to take 1 divided by this fraction here. Okay, now, we know when we have 1 divided by anything here, we would just take its reciprocal. So it'll be R1, R2, R3, all over R2, R3, plus R1, R3, plus R1, R2. And this right here is actually your final answer. It's a little lengthy, but that is the final answer. Now, we move on to C. It says, redo part A using a new formula from part B. How do the answers compare? All right, so they want us to take our new formula. So we would have R is equal to R1, R2, R3, all over R2, R3 plus R1, R3 plus R1, R2. Now we're going to substitute in our values. So we have 4, 8, and 12, which we were given up here. R1 is 4, R2 is 8, and R3 is 12. All divided by, this would be 8 times 12 plus 4 times 12 plus 4 times 8. So this would be, let's see, 48 and 8. Let's see, 48. And that's 204, if I'm not mistaken. Yeah. Divided by, this would be, what's this, 96 plus 48 plus 32. Yeah, 204 all over. Let's see. Okay, class, I made a little error here. Your numerator for this fraction is actually supposed to be 384, not 204. And then your denominator here is supposed to be 176. So when you put this in your calculator, it will give you 2.18 ohms. Well, approximately 2.18 ohms. So it gives the same answer. Even though it looked different, it gave you the same answer as your original equation did. So that was basically it for problem number 2. Now we move on over to problem number 4. Okay, problem number 4. It says you decide to buy a new car, but you are concerned about the amount of the monthly payments. The amount A of each monthly payment is modeled by the formula where A is equal to pi divided by 1 minus 1 over 1 plus I to the n power. Okay, it says I is the monthly interest rate, and N is the number of monthly payments, and P represents the principal or the amount borrowed. The car you are looking at costs $16,000 at 1% monthly interest. If you want to pay for the car over 60 months, how much will your monthly payment be? So let's write out the information. The principal is $16,000. That's the initial cost. The I stands for the monthly interest rate, which is 1%, which we'll write as a decimal. And then the N is the number of payments, which would be 60. So now we just go through here and substitute. So we have A is equal to, we have 16,000 times 0.01 all over 1 minus, I don't know why I want to do a parenthesis, 1 minus 1 over 1 plus 0.01. And we'll take that parenthesis to the 60th power. I don't know why I'm parenthesis crazy. But let me rewrite this because that didn't come out that good. So we'll have A is equal to 16,000 times 0.01 all over 1 minus 1 over 1 plus 0.01. And that would be taken to the 60th power. Now, when we put all of this in our calculator, our answer will come out to be approximately $355.91. Now, we round to 2 decimal places because that's typically how we do our money. So we would do that in this case as well. Now we come here to B. It says simplify the complex fraction on the right side of the original formula. And then we look at C. C basically wants us to do what we did in a former problem. We're going to take the information we had and then put it in and see if we get the same or different answer. So they want us to get rid of the complex fraction from being in our denominator. So we will have pi or pi all over 1 minus 1 over 1 plus I to the n power. Okay, so now we want to get rid of this complex fraction, but before we do that, we have to make sure we have a common denominator with this 1, and it's 1 over the 1 plus I to the n. So what we could do, we could change this to just be this 1 here. We can make this 1 plus I to the n over 1 plus I to the n minus 1 over 1 plus I to the n. Because we know anything except 0 divided by itself is 1. So now we will have pi over 1 plus I to the n minus 1 over 1 plus I to the n. Okay, so now we could take this p times I and write it out as regular division. So it'll be 1 plus I to the n minus 1 over 1 plus I to the n. Now, this would be pi, we could put that over 1. Division becomes multiplication. 1 plus I to the n over 1 plus I to the n minus 1. Now we multiply, and we have p times I times 1 plus I to the n power all over 1 plus I to the n power minus 1. So that is our formula rewritten. Now, we got to go to C. We got to substitute and see if we get the same answer here. So matter of fact, I would start C here. Now P, we know is 16,000. I is 0.01 times 1 plus 0.01 to the 60th power all over, actually I was supposed to write A is equal to, all over 1 plus 0.01 to the 60th power minus 1. Now when we put all this in our calculator, we'll end up with the same value, $355.91. So we could write the answers are the same. Okay, and we just finished up section 5.6. Now we're going to move on to section 5.7. So let's see what page that's on. Section 5.7 is actually on pages 559 to 562. All right. And these problems here for 5.7, we're only going to cover problem 3 and also problem number 7. So we'll cover 3 and 7. So I got to go to page 559. Okay, it says the following table gives the number of undergraduate students receiving federal Stafford loans over a period of 7 consecutive years. So it says the data can be modeled by the function n of x. Let me write this function down. N of x is equal to 1.222 square root of x plus 0.24 plus 3.442. Now it says determine the n-intercept. What does this intercept represent in this situation? So this will be 3a. Now the n-intercept is basically when x is going to equal 0. So the n-intercept is the same thing as saying the y-intercept. So we'll put in 0 for x. And we could put this into our calculator. Let me pull up the calculator. So we would have 1.222 square root of, it'll just be 0.24 because 0 plus 0.24 is just 0.24. And then plus 3.442. So our final answer here would be 4.04. Now, of course, since it's an intercept, we have to write it as an ordered pair. So it'd be 0, 0, comma, 4.04. And what this means is in the first year, the data was collected approximately 4.04 million undergraduate students receive Stafford loans. Okay, now B. It says complete the following table using the given equation. How well does the equation represent the actual data? Okay. So they want us to take our new equation, or our equation, and then compare it to the actual data. So this would be x and then n of x. So it'd be 0, 1, 2, 3, 4, 5, and then 6. Okay, so now they want us to take these values here and put it into the equation that we started with to see how it compares to the actual data. So let me pull up the calculator. Then we could type in, instead of using n of x, I'm going to put y is equal to 1.222. And then we'll do our square root of x plus 0.24. And then plus 3.442. Okay, now we'll hit this wheel here. We'll hit this table. And then we could start adding in the values. Now, they did have some values for us already. But we're interested in just going up to 6 for x. Okay, so these are our values. So now we would substitute these values into our table. So I'm going to write these values out so then I could close off this calculator. All right. So these are our values. Now we're asked, how does this compare to the actual data? And as we can see here, it's a little lower than the actual data until we get to the last 2 years. So basically we say the equation matches reasonably well, although not perfect. So it's close enough for us to be able to use this equation, but we know that it's not perfect. Okay, so now we move on to problem number 7, which is on page 561. All right. So with problem number 7, let's see, it says for each of the given functions, do the following. Determine the domain, determine the x and y intercept, and then sketch a graph. Okay, so the domain is basically telling us what x can and cannot equal. So that's what we're going to start off with. So basically, we know we do not want any imaginary numbers. So we have h of x is equal to the square root of 2x plus 3. So that's basically telling us the square root of 2x plus 3 must be greater than or equal to 0. It can't be less than that. So what we could do, we could square both sides. So we had 2x plus 3 is greater than or equal to 0. Subtract 3 on both sides, and 2x is greater than or equal to negative 3. Divide each side by 2, and x is greater than or equal to negative 3 halves. Okay, so now our domain would be x is greater than or equal to negative 3 halves is our domain. So this is our I. Our I2, we want the x-intercept. So our I2, or the two i's we have here, the x-intercept will be this value here, which would be a negative 3 halves, 0. Because we know at a negative 3 halves, that will make our y value equal 0. So negative 3 halves, 0 is our x-intercept. And the y-intercept when x is 0 would be 0 comma square root of 3. That would be our y-intercept. So now for number 3, we're actually going to put that into our calculator. So let me pull up the calculator. And we would just put in y is equal to the square root of 2x plus 3. Oh, didn't do it. Plus 3. All right, let me turn this off. Okay, if you look at this graph here, this is a representation of the graph. And it just goes on forever. Let me expand this out a little bit so you can see it better. So this is a visual representation of the graph. All right. So now we will go down here to 7b. Redo 7b. All right. So 7b. We have f of x is equal to negative square root of 4x plus 8. We just set this radical equal to 0. So you have the square root of 4x plus 8 was greater than or equal to 0. We could square both sides. And you have 4x plus 8 is greater than or equal to 0. We'll subtract 8 on both sides. And 4x is greater than or equal to negative 8. Divide each side by 4. And x is greater than or equal to negative 2. Okay, so that takes care of I, which is the domain. Now we go to the double I here, or the Roman numeral 2 with the lowercase i's. So then we need to graph this. So, well, let's find the x-intercepts, the x and y-intercept. Now the x-intercept, we see here, the x-intercept will be negative 2, 0, because that's when this will equal to 0. So this is the x-intercept. The y-intercept, we put in 0 for x, and 4 plus 8 is 12. So it'll be the negative, 4 times 0 is 0 plus 8 is 8. So it'd be the negative square root of 8. Well, 0 comma negative square root of 8. This would be your y-intercept. 0 negative square root of 8. Now we go to 3. 3 is just basically us graphing it. So we will go here to our Desmos. Let me turn this graph off. Or better yet, no, I'll leave it on and then just change this. So we have y is equal to, we'll put the negative sign out front, and then it'll be 4x plus 8. And then if you notice here, we have our graph. And I can expand this out so you can see what it looks like expanded out. Okay. So now that took care of 7a and b. Now we have 7c. So we go here to 7c. 7c is g of x is equal to square root of 5 minus x. Now we would take this square root of 5 minus x and set it greater than or equal to 0. We would square both sides. And you have 5 minus x is greater than or equal to 0. Subtract 5 on both sides. And negative x is greater than or equal to negative 5. Now we would divide each side by negative 1. And x is greater than or equal to 5. Because you have to change, well, actually it's supposed to be less than. Because we were supposed to change the direction of the inequality. So as x is less than or equal to 5. Okay, now, so that took care of our I. So this is the domain. Now we need our x and y intercept. Now our x-intercept has already been determined for us. So our x-intercept will be 5, 0. Now our y-intercept, we go back here and put in 0 for x, and then it'll be the square root of 5. So it'll be 0 square root 5. That'll be our y-intercept. Okay, and then 3, we would just graph this. So let's go here. Actually, I didn't turn the page here. But okay, so we would graph this. Let's go to our Desmos. So I change this a little bit. Take this negative out. And then it'll be what? 5 minus x. Yeah, 5 minus x. And as you see, here's our graph here. And here's the visual representation. And we're done with problem number 7. And we are done with 5-7. Okay, so now we're going to move on to 5-8. Now let's take a look. So 5-8 is on pages 567 to 570, and we're to do 1 through 9 odd. So let me go here. We're actually going to start, let's see, page 570. Oh, made a little error here. It's 567. Oh, I put in the last page. So it's page 567 that we're going to. And we're going to do problems 1 and 3 off of this section. So we look here at problem number 1. It says solve the following equations or determine which does not have a solution. Let's see. It says explain your reasoning or verify your solution. Okay, so with that being stated, we look at A. We have the square root of 2x plus 1 equal 3. Now we know with this problem here, like we did in 5-7, we got to get rid of this square root. And we do that by squaring both sides. So this will give us 2x plus 1 equals 9. We subtract 1 on both sides, and 2x equals 8. Divide each side by 2, and x is equal to 4. Now, we have to check this. This is the way how we could tell if this works. So we got x equals 4. So we're going to put in 4 for x in the original problem. So we add 2 times 4 plus 1 equals 3. So this would be the square root of 8 plus 1 equals 3. Square root of 9 equals 3. 3 equals 3. So it checks. So we know this works. All right, now we go to 1b. We add the square root of x plus 1 plus 5 on the outside equals 1. So we could subtract 5 on both sides. We add the square root of x plus 1 equals negative 4. We'll square both sides. And we have x plus 1 is equal to 16. Subtract 1 on both sides, and x equals to positive 15. Now we could go back and check this. So we have the square root of 15 plus 1 plus 5 is supposed to equal 1. Square root of 15 plus 1 is the square root of 16 plus 5 equals 1. So this is 4 plus 5 equals 1. And we know 9 does not equal 1. Okay, so there is no real solution to this problem. Okay, now we go to C. We have the square root of 2 minus x is equal to negative x. Now, we will square both sides. So this will give us 2 minus x is equal to x squared. All right, so we need to get all of these on one side. So we can add x and subtract 2 on both sides. So this would be 0 is equal to x squared plus x minus 2. Now, we've been through factoring. So when you factor this out, you would get x plus 2 and x minus 1 when you factor this out. Now, we would set both of these equal to 0. X plus 2 equals 0. X minus 1 equals 0. Subtract 2 on both sides. X is negative 2. Add 1 on both sides, and x is 1. Now, we have to check and see if this works. So, first I'm going to try the negative 2. So we have the square root of 2 minus a negative 2 is equal to the opposite of negative 2. So this would be the square root of 4 is equal to 2. And we know 2 equals 2. So we know x equals negative 2 works. Okay, so we could say it checks at x equals negative 2. Now we're going to try the 1. So we would take the square root of 2 minus 1 is equal to the opposite of 1. Square root of 2 minus 1 is the square root of 1 equals negative 1. And 1 doesn't equal negative 1. So this does not check. Does not check at x equals 1. So your final answer here would just be x equals negative 2. All right, so now we move on to problem number 3 on the next page. Now this will be our last problem. And again, if you have any questions, you could always email me, come to office hours, come to class, and I will gladly answer any of your questions. Okay, so number 3. 3a, we have the square root of x plus 5 equals 1. It says solve each of the following equations algebraically and by graph, and be aware of any extraneous roots. Okay, so first thing we would do here, square both sides. So this will give us x plus 5 is equal to 1. Subtract 5 on both sides, and x equals negative 4. Now, we will put that back into the original problem. So we have the square root of negative 4 plus 5 equals 1. This will be square root of 1 equals 1. 1 equals 1. So it checks. So x equals -4, checks. So now we look here at b. We have 10 times the square root of x plus 2 is equal to 20. We divide each side by 10 first. So this would be the square root of x plus 2 is equal to 2. Now we would square both sides. And this would be x plus 2 is equal to 4. Subtract 2 on both sides, and x is equal to 2. Now we will go back and try 2 in this problem. So we had 10 times the square root of 2 plus 2 equals 20. So it'd be 10 times the square root of 4 is equal to 20. Now we know the square root of 4 is 2, so it'd be 10 times 2 equals 20, and 20 equals 20. So x equals 2, checks. So now we go to C. We have the square root of 5 minus x is equal to x plus 1. So we would square both sides. And this will give us 5 minus x is equal to, now x plus 1 parentheses squared. We know that this factors out to x squared plus 2x plus 1. Now you can multiply that out, and just to give you a little jump start, you would do x plus 1 times x plus 1. And that will give you this here. So we need to get everything on one side, so we can add x and subtract 5 on both sides. So it'd be 0 is equal to x squared plus 3x minus 4. Now this doesn't, well, how's it a 4 and 1? Yeah, this does factor. We could do x plus 4 and x minus 1. Now we set both of these equal to 0. X plus 4 equals 0, x minus 1 equals 0. Subtract 4 on both sides, and we add -4. Add 1 on both sides, and we add x is 1. Now, we have to check these like we did the other one. So, we would take the square root of 5 minus a -4 is equal to -4 plus 1. So, this would be the square root of 9 is equal to -3. 3 does not equal -3. So when x is -4, does not check. So we know that's not one of our solutions. Now, we're going to try 1. So we would take the same equation. We have square root of 5 minus 1 is equal to 1 plus 1. So it'd be square root of 4 is equal to 2, and 2 equals 2. So x equals 1, checks. All right. So now, the last part of this activity, we were supposed to do this in our calculator. So what I'm going to do, I'm going to pull up our calculator, and I'm going to turn this off. And I'm just going to graph, well, I guess I could graph the last one. Okay, so we want to see their intersection point. So with this here, we'll set both sides. Let me move this over here. We'll set both sides of this initial equation equal to each other. So we will have y, not equal to each other, but y equals to each separate side of the equation. So that's one graph. So now we would do y equals x plus 1. And here's the other graph. And if you look here at their intersection point, they only intersect at 1. So we just proved that graph, and I can expand it out so you can see it fully. They only intersect when x is 1. They do not intersect when x is -4. Okay, so now that took care of C. And I think I'm just going to do B, and then A you could try on your own. But let's look at B. Same setup. We're going to take the initial equation and set both sides y equal to both sides. So over here, we could do y equals 10 and the square root of x plus 2. Okay, that's one graph. Now the next, we'll do y is equal to 20. And then here, we can expand this out and we get their intersection point, which is at 2. And so we prove that it also works graphically. Now, we are actually done. So what will happen now is that you will finish up all the rest of the work and also include the work I went over with you. And please, if you have any questions, please email me. Have a wonderful day.